So question 8 from the practice exam, we're asked to evaluate all of these Lewis structures and come up with what is the, click on the resonance structure that's the most stable. So again, we want to kind of ask ourselves those questions of, did I violate the octet rule anywhere? So going through and looking at these, right, I don't think we violated the octet rule anywhere. Everything, all right, that's got 8, 8, and 8. Got 8 here, 8, and 8. So everything looks good with respect to the octet rule. So then number 2, we want to go through and check formal charges. So for formal charges, all right, nitrogen is 5, carbon is 4, oxygen is 6. So our group number 5, 4, 6, 5, 4, and 6. And then next are assigned electrons. So if we take a look at nitrogen in the first structure, we're going to have 5 assigned electrons, 1, 2, 3, 4, and 5. If we take a look at carbon, I've got 1, 2, 3, 4. And take a look at oxygen, I'm going to have 1, 2, 3, 4, 5, 6, and 7. So this first one, right, -5, -4, -7. So neutral, neutral, and -1 charge on our oxygen. The next one down, right, oxygen, nitrogen, sorry, has got 1, 2, 3, 4, 5, and 6. Carbon has 4, and oxygen also has 6. So -6, -4, -6. So that would be 0, 0, and -1. And then the last one, we see that nitrogen's got 1, 2, 3, 4, 5, 6, 7 electrons assigned to nitrogen. We still have 4 electrons assigned to carbon. And then we've got 1, 2, 3, 4, 5 electrons assigned to oxygen. So -7, -4, and -5. So we've got a -2 charge, a 0, and a +1 charge on the oxygen. So number 1, we want to have the fewest, if we have to carry charge, we want the fewest atoms carrying charge. So we can put a big red X through this Lewis structure because that one's got 2 atoms carrying charge. And the other thing that's not nice about that is if we have a negative charge, we want to have that negative charge on the most electronegative element. So we don't want a positive charge on oxygen. So given that we want to have a negative charge on the most electronegative atom, oxygen, right, it's closer to fluorine than nitrogen is. So oxygen's more electronegative. So the best resonance structure is the structure that puts that negative charge on oxygen. That would make that one better than the resonance structure that has a negative charge on nitrogen.
Does it matter with the bonds, like since nitrogen bonded? That doesn't matter, it's just having the negative charge on those.
It would matter. So does it matter how many bonds nitrogen has or carbon has? It would matter if carbon didn't have a full octet or something like that. In this case, it doesn't matter that carbon has a triple bond and a single bond or 2 double bonds, because in all 4 of those cases, carbon has a full octet. So yeah, that doesn't matter. It would have mattered if we had a double bond and a single bond and then nothing else on carbon, because that would be a violation of the octet rule for carbon. So no, it doesn't matter. Are we comparing a double bond with a triple bond or a triple, 1 triple and then 2 double bonds, as long as we've fulfilled the octet rule for those elements involved. Yeah.
For electronegativity, how do you determine which one's the most stable?
Yeah, so the electronegativity trend that we had to consider, right, when figuring this out, is, basically fluorine is the most electronegative element. in general, electronegativity increases from the lower left to the upper right-hand corner. So I don't expect you to know exact numbers of electronegativity, just the general trend. So as if fluorine is the most electronegative, that means as we're going across from carbon, nitrogen, oxygen, and fluorine, we're becoming more and more electronegative. So in this case, nitrogen, carbon, and oxygen, well, oxygen is closest to fluorine. It's the most electronegative. Carbon is the farthest from fluorine. It's going to be the least electronegative.
So it goes from left to right.
Yeah, in general, it's going to go left to right because, right, our trend increases from the lower left to the upper right-hand corner. That also means that our electronegativity would decrease down a group. So like iodine would be less electronegative than fluorine. So that trend would also work down a group as well. If you had to compare, sulfur to oxygen or something like that.
So for bromine, it would be the lower.
Yeah, so fluorine would be the most electronegative, followed by chlorine, then bromine, then iodine would be the least electronegative of that group.
And then what other ones to the left to the right?
So no, because then we would be, right, if we're moving to the left, we're becoming less electronegative. So selenium would be less electronegative than bromine because now we're moving the opposite direction of our trend.
Gotcha. And the noble gases are electronegative.
Yeah, because our noble gases have a full octet of 8 electrons. So they don't want to pull, they have no reason to pull more electron density toward themselves.